Hello, all conference participants. Today I will present you an article Research of Antispam bot algorithm for social network. The project was created by me, Oliinyk Vasyl, Andrii Podorozhniak, and Liubchenko Nataliia. Let's make a little view on the structure of my presentation. We will start with an introduction and the ways to deal with spam. Then we will discuss all of the algorithms that have been used in our project. And finally, we will see the results, the test results of the algorithms, and I will summarize the results. The percentage of the spam messages in the global mail traffic is continually increasing. As you can see on the graphic, in 2019, it was 56.51%, that is 4.03% more than it was a year ago. Of course, there is not as much spam in chat rooms as in mail services, but the cost of an extra message can cost some money. So let's first talk about characterization of the spam. Spam is a mass mailing of the information to the people who have not expressed the desire to receive it. Here you can see some typical types of the spam: advertisement, Hungarian emails, phishing, and so on. So what are the ways to deal with spam? The best way to deal with spam is to prevent spammers from getting hold of your contacts. The anti-spam filters help to solve the spam problem. This software has two main approaches. The first one is the algorithm analyzes the content of the message, and based on the result, it decides if the message is spam or not. The second one is it classifies the sender as a spammer without looking at the content of the message, but it can work only on the server side. Let's make a little and quick view of the used algorithms. The first one is the naive Basin classifier. It's a probabilistic classifier that is based on the Basin theorem. On the one hand, this algorithm works even on the small size of the samples, but on the other hand, works only when the assumption of the independence of the input items is satisfied. Here you can see a Basin theorem. P from A and P from B are the probabilities A and B without relation to each other. P from A slash B is probability of observing event A if B is true, and P from B slash A is the probability of observing event B if A is true. The next algorithm that was used is the support vector machine. It is a supervised machine learning model that uses classification algorithms for two-group classification problems. It divides the sample in two classes, and the new input will be assigned to one or other category. If the data is not linearly separable, then it maps the primary finite-dimensional space into a space with more dimensions and splits the data in a new dimension. The third algorithm is a Perceptron. It is a computer model of information perception of the brain. It consists of three types of elements: signal, sensor, and corrective elements. It literally sets the association between inputs and outputs. And the last algorithm that we have used is the convolutional neural network. The convolutional neural network, or CNN, is a specialized type of neural network model designed for working with two-dimensional image data, although they can be used with one-dimensional and three-dimensional data. Central to the convolutional neural network is the convolutional layer that gives the network its name. This layer performs an operation called the convolution. Convolution is a linear operation that involves the multiplication of a set of weight with the input. Much like a traditional neural network, it maps the input data to the specific feature maps. Then, based on these maps, the result will be received. CNNs are not limited to image recognition, however, they have been applied directly to the text analytics. Each fragment is multiplied element by element by the small matrix of weight, and the result is sum up. For CNN, vectorized text is fed to the network input instead of matrices representing a picture. The dataset for testing our project was taken from Google. The name of the dataset is SMS spam collection dataset. On the slide, you can see the structure of the dataset. It has two columns. The first one defines the class of the message, and the second one maintains the actual message. We have converted spam ham class representation to 0, 1, when 1 is a spam and 0 is ham. Then we have vectorized each message. Vectorization is the process of transforming this text into a meaningful array of numbers. You can see this process on the image below. Then we have removed the messages that are repeated more than 1000 and less than 5 times. The result dictionary contains 1191 words. Here you can see the structure that we have used for the Perceptron multi-layer neural network. The first layer consists of 1191 inputs as the size of the dictionary, the second one of 64, and the third one of 16. These slides represent the general scheme of the developed software. As you can see, there is a probability, there's a possibility to choose the algorithm for work. This is the configuration of the computer that was used for the test. Here you can see the results of the test on training and test samples. As you can notice, the best is SVM with 98.9% accuracy of spam recognition. Here you can see the comparison of two neural networks on different samples. As it's shown on the test sample, the CNN is 0.6% better than NN. This slide displays us the result of the test of two neural networks using F1 measure. And here you can see the results of tests using F1 measures for all used algorithms. The dummy algorithm that returns always ham for every message was also tested. And here you can see the results of the tests using F1 measure for all used algorithms. The dummy algorithm that returns always ham for every message was also tested. On this slide, you can see how CNN works depending on the count of the epochs. As you can notice, 10 epochs is the optimal value. Here the same for NN, but on the 10 epochs it's overfit. So the 5 epochs is the optimal value for NN. Also, we have tested the 3 best algorithms using majority function. We get the prediction from the 3 algorithms, and if the mistake of the recognition is more than 5%, we don't take into account the result of the recognition of this algorithm. And here, finally, you can see the testing algorithms on training and test samples. So during the research, it was considered the relevance of the spam detection and the possible ways to deal with spam. The basic methods of the spam recognition were discussed, and as a result of the project, it was developed the program to filter the spam messages in Telegram channels. The created algorithm Antispam bot uses the majority combination of three implemented battle algorithms for spam recognition. It has accuracy of 99.9%, and F1 score is 96.5%. And it can be used in real-time systems. And on this slide, you can see the working of anti-spam bot. Thank you for your attention.